Alright, and welcome to section 5.1 video. Let me go ahead and clear the screen so we can have a nice clean screen. And here are the notes that we covered in class. So we're starting with section 5.1. And in this section we're dealing with rational expressions, which basically means that we're dealing with fractions in a sense. So rational expressions, and I'm going to begin with obviously example 1. And so in example 1, they want us to evaluate a rational function, and so they're going to give us a rational function. Here we go. Our rational function given to us is basically this. It's given, and g of x is equal to 2 over x minus 3. So I want you to go back and remember fractions, and remember that this fraction, or this part of the fraction, can never equal 0. So the value here, if I were to take x minus 3 and set it to 0, obviously I would add the 3 on both sides, and this would give me x is equal to 3, which is exactly the value that x cannot be, because if it is, this becomes undefined. Okay? Now in example 1, they basically want you to substitute, so they're asking you to determine the value if it exists. So they give you, for example, g of 0 for part A. For part B, they ask you for g of 1. For C, they ask you for g of 2.5. For part D, they ask you for g, let's go with g of 3 as one example, and I'll do one more. I'll do g of 4 just to get the message across. So if we look at the rational function here, and we start with part A, you can see that we're going to have 2 over 0 minus 3, which simply results in negative 2/3, and that's okay. In part B, we have 2 over 1 minus 3, because I'm substituting in 1 for x, and if you notice in this case, you end up with negative 1. Because you end up with 2 over negative 2, which is negative 1. For part C, we're going to substitute in 2 over 2.5 minus 3. And so in this case, since I'm substituting in 2.5, I end up with 2 over negative 0.5, which is basically the equivalent of 2 over negative 1 over 2. So in theory, what's happening here is that you have 2 over 1, which is this top part, divided by negative 1 over 2. And so if I engage in the solution, I will have keep, change, and flip of this fraction. Oh, excuse me, didn't flip it. So this will be negative 2 over 1. And as a result, we end up with negative 4 as our answer. So remember, this is a video, so even if I go quickly or not is irrelevant. You can always stop it and proceed as you need, okay? Part D, I gave you 3. This is actually up here already worked out for you. If I were to substitute in 2 divided by 3 minus 3, I end up with 2 over 0, which we know as an undefined fraction. So that would not work as a solution. And last one I gave you was E. So I'll do E up there. In E, I substituted in 4, so I have 2 over 4 minus 3, and so our answer for that should be just plain old 2, because this results in 1. So you really have 2 over 1, which is 2. That's example 1 of this section. I did quite a few examples there. Okay, in example 2, we get a little deeper into the material. And in example 2, the first thing we talk about is locating the domain or finding the domain of a rational fraction. I'm just going to put RF at this point. And so we begin with example 2a, where I have f of x is equal to x plus 4 divided by 2x squared minus 11x and plus 5. And so what I want you to keep in mind is we're really focused on the denominator. What value can the denominator not hold? And so to do so, you actually have to factor this. So I'm thinking, let's factor this with 2x and x. Keep in mind that the only factors of 5 are 1 and 5. So if this is a minus 1 and this is a plus 5, let's see here. This will give us, no, this has to be negative also. Of course, because that's the only way that the inner outer are going to add up to give me negative 11x. Now we set these to 0. So you go back to the concept that we talked about in the other section, where if we take 2x minus 1 equal to 0, and we solve for this, I will add the 1 to both sides, leaving me 2x is equal to 1, and then I will divide by 2 on both sides, giving me x is equal to 1/2. On this side, if I take the x minus 5 and I set that to 0, this is going to give me x is equal to 5. Okay? And so in this case, keep this in mind. If we look at set builder notation, so we would say where x is a real number, okay, that's a number sign, so real number, but, or and, x cannot equal positive 1/2 or positive 5, and then you close your notation. In interval notation, okay, now I want you to think number line on this one. So this is set builder, by the way. Let me just write this out for you so you see it, you hear it. Set builder notation is this. Interval notation, we begin with a number line just to start the logic that this is negative infinity, this is positive infinity, right? We then locate the value of 1/2. So let's say this is 0, I'll say this is 1/2, and say this is 1, obviously half, this would be 2, obviously in a half, this would be 3, obviously a half, this would be 4, it's just a bit, so extending line, so this would be positive infinity, so a half, and here's your 5. So according to this, if you look at this being the negatives on this side, here's negative 1, I'm just skipping the halves, negative 2, negative 3, and so on. Alright, and so technically, we would engulf all the negatives, so negative infinity, coming up all the way to 1/2, non-inclusive union. Again, you would use parentheses, the 1/2, comma, up to the 5, non-inclusive, union. Again, parentheses, and then 5, comma, positive 1/2, or, oh my goodness, positive infinity, and then close it up. So the way it looks is you're coming from infinity, so you're kind of like grabbing the infinity, going up to the half, not including the half, grabbing the half, not including the half, up to 5, not including the 5, and same thing from here to here to positive infinity, where we will be closing out. Alright, so that's how you would deal with that. So notice that I focused strictly on this denominator, factored it, when you factored it, you find the actual values that make it equal to 0, which we do not want because it is a denominator. Because it's a denominator, if this were 0, if I had x plus 4 over 0, then all of this would be undefined. Okay? Alright. Let's look at simplifying a rational expression before we go into solving for the solution. So if we're simplifying, which is example 3, we're looking at 2x cubed plus 12x squared plus 16x, and all of this is over 6x plus 24. So I'm immediately thinking factor away. So the first thing I want to factor, obviously, is the denominator. So I know that if I take out a 6, I'm left with x plus 4. The 6 is irrelevant to me. It's the x that matters. This x, if I say, okay, then x plus 4 is equal to 0, which is what I don't want, then x would have to be negative 4, which is what I don't want. Again, because we don't want this to be 0. And so, if I factor both the numerator as well, say for example up here I take out a 2x and I'm left with, in this case, x squared plus 6x plus 8. I know that I could factor that further, so I would have 2x parentheses, let's go with x plus 2, x minus 2. Alright, and so what we know about this is that technically, what am I doing? I'm sorry, I'm thinking of a totally different question. Let's try that again. X plus 4 and x plus 2, because these are both positive. There we go. What happens here is that you end up solving 2x, x plus 4, and x plus 2. And all of this, once factored, would be 6 over x plus 4. So you notice that if you're not careful, you're immediately going to reduce the x plus 4 out of the equation. And you're left with 1/3, which will leave you with x plus 2 over 3. And you'll be under the impression that there is no value that needs to be eliminated. In this case, you have to understand that this is a restriction. So initially, focus on factoring the denominator, which gives you the restriction of negative 4. Now, your final solution will be this, but the elimination is that x is never equal to 4. Okay, and so your final solution is that. Alright, so that one, just keep that in mind. You always go back to the original value here, which is in the denominator. Make sure you eliminate that. Then factor the numerator, and then if you notice, after I do that in the second step, so this would be like your step 2, then we start looking at, and obviously this is step 1, then we reduce right here, and that would be your final answer, but you always have to remember the original restriction. Okay, let's take a look at example 4. In example 4, it says simplify. And in this case, I have 2x squared times y to the 8th over 8 x to the 4th y to the 3rd. And one of the things that I have said to you guys is if you have trouble with subtracting the exponents, which some people still get a little confused, think of a visual that I give you. So forget about the 2 8s. We know that that reduces to 1/4, right? Because 2 goes into 2 one time and 2 goes into 8 4 times. So we're okay with the coefficient. It's here where I see most of you always have a little bit of a glitch. So I'm going to take my time with this one, just show you visually what it looks like in terms of what you're subtracting and why you do this process. So these are all multiplication. There's multiplication in between all of these, respectively. Here we have x times x times x times x, and the y's happen y times y times y times. That's how many powers we have. So if I have 3 powers of y, I'm going to take away 3 powers of y. I have 2 powers of x, which I'm going to take away 2 powers of x. So if you look carefully, look at what I have left. I have 2 x's in the bottom. I have 4 y's on the top. Make that 5 y's on the top. Alright, so what you're left with is in essence the same thing you would have originally gotten had you subtracted straight down. So 2 minus 4 gives you negative 2. You would have still had to leave these down here. 8 minus 3 on the top would have given you 5, so the 5 would have stayed up here. So it looks like this. You would have had, in this case, the 1 over 4, that's irrelevant. That's the coefficients, that's way easy. For this one, you would have gotten x to the 2 minus 4, and over here you would have had y to the 8 minus 3. So notice that these are all 1's now, right? Look at them separate. So this would have given you 1x to the negative 2, y to the 5th. We're okay up to the point where the x to the negative 2, which means that I need to break this down to y to the 5th over x to the positive 2. Remember I said bring it below the fraction bar, and the sign in front of the exponent will reverse itself. Alright. Notice that I have 5 y's in the diagram. Notice that I have 2 x's in the diagram. You have a 4 in the denominator times all of this stuff. So this is 4x squared in the bottom. Okay, so that's like kind of like the long way to explain this. So let's do one the short way just for the sake of not confusing those who know it the short way. Remember, this is b to the 1. We don't write the 1. Okay. So looking at the coefficients, 9 and 18, obviously that reduces to 1/2. We're okay with that, right? Here I have a to the 5th, a to the 8th, which means that I have the a to the 3rd remaining in the bottom, because I have 3 a's that will be left over. B to the 3rd over b to the 1 means that this will be b squared. So your final answer for this will be b squared over 2a to the 3rd. Okay? Alright, let's look at example 5. Example 5 is simplifying a rational expression. So they still say simplify. They're giving you t to the 3rd plus 8. Already your spidey senses should be going off that there is some cubic involvement here, right? And this is over t to the 2nd plus 4t plus 4. So immediately as I factor, I'm thinking this is a t plus 2 times t squared minus 2t plus 4. Remember the cubic function formula. If I look at this carefully, this has got to be a t plus 2 times t plus 2. Okay? Now immediately I want you to start to think the restrictions. I don't think t can ever equal negative 2. So t equal to negative 2 is not happening, because that'll make this denominator 0. You then have to keep in mind that technically what's going to happen here is that one of these is going to cancel with the other, And so that's why you have to still be careful with your factors, because if this happened to be a different value, it would make a difference. So here we have t squared minus 2t plus 4, and all of this is over t plus 2. Alright, so that's not terrible if you can remember your equation for cubic functions, which I have gone over with you. Okay, and the last example here is example 6. In example 6, we're simplifying this rational expression. Notice that this is x minus 5 over 25 minus x squared. So it is obvious that this is x minus 5 over 5 minus x times 5 plus x. Alright, do you notice that there is a negative involved in there somewhere? As in, if I were to take negative 1, and I could potentially use this up here. If I extracted a negative 1, this would reverse the x as negative and this is positive, because it reverses everything, right? And so this is really now 5 minus x with its negative 1 out here. Technically, this would cancel at this point, wouldn't it? So the 5 minus x's would go away, and you would be left, in this case, with negative 1 over 5 plus x, which is what's left over. Or if you chose to take the negative here and then leave this as 1 over x plus 5. It's up to you. Either way it works. And these are both solutions. And that is a summary of 5.1 in your textbook.